open to ideas. All the way at the back in the dark blue shirt.
Speaking of the external tank, you happy with the problem solving on the breakaway fall?
Good question. The question was, speaking of the external tank, am I happy with the problem solving on the foam issues that brought down Columbia? Yes, I am. Very happy. If you've seen any of my press conferences since before return to flight, you'll know that I've personally stayed right on top of that all the way along. And we have eliminated most of the sources of foam debris. Those that we couldn't eliminate, we've modified so that they shed foam in smaller pieces and at times which are not harmful. If foam comes off very early, it's not an issue because it isn't going fast enough or the orbiter is not going fast enough to be a problem. If foam comes off very late, it's not a problem because you're essentially above the atmosphere and the foam does not accelerate into the orbiter. So one way or another, we've taken care of everything we know. Now, everyone always takes care of everything we know. We've also done our very best to make sure that we've looked for all the unknown unknowns. I'm really happy with what the guys have done in making a safer external tank. In the blue shirt?
Hi, Alderscan Oshkosh Northwestern. So
Speak up.
Alderscan Oshkosh Northwestern. Other than the Mars and Moon stuff, which is great, what other future projects is NASA looking at?
Well, other than Mars and Moon stuff, which is great, what other future projects is NASA looking at? Well, a third of our budget goes to science. So, I mean, we're looking at programs like Mars sample returning samples from Mars. We're looking at what kind of interesting scientific work will be done on the moon when we return to the moon. For example, the moon is an ideal place to lay out large radio telescopes that simply can't be built on Earth. We're renovating our Earth science program. We're conducting more missions to the outer planets than have been planned in the past. And we're doing a lot of new advanced aeronautics work on things like blended wing body designs and more efficient fuels. So, you know, across the board, we're doing, I think, a lot of good stuff. Well, there's a gentleman back here in a black shirt who's had his hand up for a while. Sir?
Yeah, would it not be a true statement to say that space exploration of other planets within our solar system is a major aspect to the survival of our species, in that looking at another planet is inside of our planet, and secondly, being able to exist in space and protect ourselves from needles?
The question was whether or not space exploration doesn't contribute to the long-term survival of the human species. I do, yes, sir, I think it does, my own opinion. I'm gratified to be joined in that opinion by Professor Stephen Hawking, whom I think is a name known to everyone, who has, over the last year or so, tried very hard to make the point that in the long run, space exploration is about the survival of the human species. We have recorded in the geologic history of our planet around 10 major extinction events, from asteroid impact, eruption of supervolcanoes, and possibly other things whose causes we don't really know. But life on Earth is precarious at best over the long term, and if we in the long run care about the survival of our species, then we need to diversify, and space exploration is the means by which we can do so. So yes, I do believe that to be one of the reasons. Sir?
How confident are you in the constellation architecture that you can solve the vibration and payload problems with the current architecture?
The question was how confident. If you've been reading news reports, you've seen that we're dealing with some vibration problems in our constellation launch architecture. I would say, frankly, most of that is media-induced. To be very honest with you, what we're talking about here is a trait that produce vibration, whether they're liquid or solid, but the particular issue we're talking about here is toward the end of burn of a solid rocket motor, it becomes a very large tube that's mostly empty, and it can resonate like an organ pipe. And one of the potential resonance points on our Ares 1 first stage would be around 15 hertz, 15 cycles per second, and that would be harmful to some of the other systems and to the crew if some of the worst case predictions for it came true. Now, we've analyzed it carefully enough to know that, first of all, the worst case predictions are about a factor of 5 or so times too big to be realistic. Second of all, these vibrations can only last for a few seconds, 4 or 5 seconds at most, if they occur. They don't always occur. And thirdly, we figured out now at least a half a dozen means to mitigate those and damp them out should they occur. And we have an actual agency decision, engineering decision meeting coming up next month, where we're going to pick the top 2 methods that we like, and we like them if they're low impact and things like that, low weight impact, to mitigate them and go forward with those. And when we do, we'll probably end up having a press conference to tell people what we've done. I'm very confident that this is, let me put it this way, I hope this is the worst problem we have in developing a new system. There seems to be a set of thinking out there that somehow or other it's possible to develop large new systems and not have any problems. And that if you have a problem, it's a cause for everybody to say, okay, engine stop, cease and desist, come to a halt, let's try a new path. This has been a bit surprising to me. Our nation never achieved anything by stopping what it was doing the first time that we encountered an obstacle. And I sometimes wonder what it is that folks think our response should be when we encounter an engineering problem.
No, it's just that you guys have done such a terrific job, we just expect the best all the time.
Thank you. The comment was that we do a terrific job and people expect the best all the time. And we have stumbled at times. NASA has stumbled. I mean, we had, the Apollo fire in '67, Challenger loss in '86, and then Columbia in '03, and we've lost